This is around two problem maybe to many of you, but I would prefer to do this in round one uh, because there is a very simple logical way of solving this question. Let me solve the method one first. Let's say m plus w is the number of units of all men and women working per day. So units per day of all men and women initially. E is extra units per day of one man over one woman. Now in this question, one man replaced one woman. So which means he brings in E units per day extra. So if the job was done in 96 days, 96 E units must have come in at the end of 96 days. This was equivalent to replacing 24 days of work of all the men and women. So that implies that 4E is equal to m plus w. Let's call this as equation 1. Now if two men had joined in, two men had replaced two women, they would bring in 2E units, and if the work was done in k days, this extra was equivalent to replacing 120 minus k when the days of m plus w units. So let's call this equation 2. Dividing the left hand sides and also the right hand sides, we get 2 by k is equal to 1 by 120 minus k, or we'll get k is equal to 80 days. So which means the job is now going to be finished in 80 days. So the method 2 actually flows from here. So if one guy had replaced, it is equal to saying 4E units are equal to m plus w units. So the total amount of work done is equal to the extra man working for 4 days. Suppose two people had replaced, then you will find that the extra that we get from both the people, let me call that a double E, must be equal to the amount of unit of all the people in one day, which means the big extra that we get is half of m plus w. So the speed now becomes 3 by 2. Hence, the time will become 2/3 of the normal time. 2/3 of 120, that is equal to 80 days. This is the second way of solving this same question.